males more than the mean of the females. See, if I was actually asking, do males take more, or in this case, since it looks like it, I might say, are the males taking less? And here's where it's going to get real confusing for some of you. Depending on how I write this, if it's a one-tailed test, I can write this either way. This will be the same, but if I sat there and said the males is less than the females, I could also say the females are greater than the males. And I'd be saying the same thing, right? And one way would set it up as a right-tailed test, and the other way would set it up as a left-tailed test. Sometimes, especially if I'm working with T, sometimes it's easier to work with a left-tailed test than a right-tailed test. So sometimes I will purposely write it so I'm always dealing with a left tail. But it doesn't really matter, because if I just think a little bit, the only difference when I'm looking at this, I still get some values here, right? Mm-hmm. Well, if it's a two-tailed test, I have both tails, right? But if it's a one-tailed test, what's the difference between these two numbers?
One is higher than the lower.
Of course.
The higher end and this end.
Yeah, but what can you tell me about these two numbers?
What's positive, what's negative?
They're going to be the same number. It's just one would be a positive and one would be a negative. So if I set something up as a right-tailed test, my tables give me my left tail much easier, but it will always be a negative number, right? Mm-hmm. So if I want it as a right-tailed test, I'm going to just write it as a positive number. So I'm going to have to think about where it's at. But the next thing I always do is I always draw my little picture. If it's a two-tailed test, I'm going to draw this. So, looking at this problem, we've got the null and the alternative hypothesis. Right? So we got that. Now, there are a couple of different ways of thinking about that hypothesis. If the mean of the males is equal to the mean of the females, that just means they're both the same. Sometimes you will see some people write this as the mean of the males minus the mean of the females is equal to what? No. Zero. So sometimes you'll see the hypothesis written this way. These both say the same thing.
That's what they want to confuse stuff now.
Well, it's just different aspects of looking at it.
Okay, I can see how that would.
Yeah.
Okay?
That makes sense.
If I'm saying they're the same, that just means if I take one and I subtract it, I get 0. Okay? And if it's not the same, that means that when I subtract them, it will not be 0. So whether you see it written like this or like this, doesn't matter. If it's a one-tailed test, it makes a little bit of difference, because if it's a one-tailed test and I write this, that's good, but my null hypothesis, this would still be the same. But if I wanted to sit there and say the mean of the males is less than the mean of the females, that's an ugly looking mu, okay, Then what, how would I write it over here?
More? Oh, I see. Mean of the
Meaning the
males.
females.
Less than.
The mean of, now, if I'm saying the mean of the males is less than the mean of the females, and I wrote this, I'm taking the smaller number, subtracting the
number.
bigger number, so I would say that this would be less than 0, which would make it what type of test? It would make it a left tail test. But if I wrote it this way,
Lost me. Too much typing.
now I'm taking the bigger number and subtracting the smaller number. And I'm saying, and this would say that would make it into a right tail test. Is there any difference?
Yes.
No.
No.
If I'm younger than you, or
Oh,
I'm
yeah.
older than you, you're younger than me, doesn't make a difference how I say it, right?
And that's assuming that the males is less?
Well, yes.
Assuming that,
Yeah.
but it could be that the other way around.
No, see, this is how I wrote it,
Because
right?
it's less.
You gotta go back over here and look how I wrote this. See, if my alternative is that the males is less than the females,
Yeah.
then I can either write it this way, and if I subtract the females from the males, then my number will be a negative number. Remember back in the beginning, I had you do that, and I had to tell you you had to tell me what the negative meant and what the positive meant?
Yeah.
See, this is back where you're in that situation again, where you always have to think about what a positive and a negative number is. See, here, the negative would mean that the females are older. So you gotta keep it in mind what the numbers are representing. So you can't just jump. You can't just memorize and plug things in. You gotta actually think about how you are answering the question that you are asking. I don't like to work with negative numbers. I tend to always write these to be sometimes right-tailed tests. However, sometimes it's easier to use the tables to find the left-tailed value, which means I have to be able to flip-flop and use the positive and negatives. So you gotta always think about that picture and which way you're going.
Left tail is negative, right tail is positive.
Without looking at it, I'm not going to answer that question because I keep telling you
I know.
I'm directionally
Sorry.
challenged.
My bad.
If I'm facing forward, it might be true. If I'm facing backwards, it might be the opposite. See, it's like when you take your car to the mechanic and you tell him you have a squeak in the left wheel.
Which left? I would say the driver's left. When you're driving, it'll be that left, right? Driver's side.
Yeah, but mechanics are always looking at your car the opposite way.
Shit. That's why you go and then you point to the wheel that's broken.
That's why you say passenger side or driver's side, because it doesn't matter.
That one is not working.
Okay. So, when we go back and we look at it, they're looking at part C. And they just talked about x bar minus x bar of f minus x bar of, which is just talking about the differences in it. Okay? So, that's what we're looking at. Is there a difference between those two numbers, or is there not a difference? Because see, that's what we're actually looking at. We're not really looking to see if they're equal, we're just looking to see if they're different between one another. That's why some people write it this way as a difference, and some people write it this way. So you just gotta recognize they both go both ways. Okay. Now, the next part says that you need to do, what's the next part after C?
And that's acting slow. It's slow again.
Somebody who's already there? It asks you to do what?
Loading.
Everybody's just loading?
Part C.
Part D.
It's still loading.
State the distribution to use for the test.
State the distribution that's used for the test. So what distribution are we going to use?
Binomial. Because it's T. Not a
Why?
Oh, shit. Well, because the standard deviation is not given.
When do we use the Z table?
The standard deviation of the population is given.
When the standard deviation of the population is given. Is the standard deviation of the population given?
No.
No, we're not even dealing with a population, are we? We're comparing two samples. So we're going to use a T table.
Why can't I click over there?
If we use a T table, what is it that we need to know?
The degrees of freedom.
The degrees of freedom. Now this is the nasty part.
I didn't go over that in this book.
Okay? Oops, where'd it
Okay,
go?
wait, what? The degrees
So
of
we have to
what?
write the
Wait,
count for
so
the males.
you have
and
males
the count
and
for the
females now.
females.
Well, we need all that information. Yeah, we're always going to need all that
I
stuff.
guess I'm trying to figure out how to write it in Excel, like how to read these information.
Okay. I'll get to that in a second.
Should be separated.
So when I start to look at this,
Finals week, we cramming the whole week.
big nasty,
Oh.
degrees of
Oh. Freedom.
freedom
Oh my god.
Gosh.
is a big nasty ugly formula.
Oh my god.
Okay? If you go and you look in La Lima, there is a spreadsheet that says degrees of freedom,
That's low.
which kind of makes it nice because we're going to pull that up so you can pull that up. What is this?
Sample ones.
Sample
Squared.
1,
Square.
Standard deviation?
standard deviation,
Twice.
To the second power?
squared,
Squared.
which is called the,
Standard error.
no,
No. Fudge.
What? Yeah, what is it called? What?
It looks like an S and a 1.
Variance.
yeah, variance. When we square the standard deviation, we get the variance. So this is the variance,
It's been too long.
no, S squared.
Oh.
The standard deviation squared is the
Variance.
variance.
We're working backward. I mean,
Okay.
upwards now.
So the so this is the variance. Now, how do we get the variance?
Yeah, or.
The
X.
mean.
We
We square the standard deviation.
we square the standard deviation. Okay. See, this is
over
going
it.
back.
Back to like the beginning of,
I know.
of time.
But see, Branson, you guys
I'm
keep
over
saying,
it.
can we ever forget anything? And the
Oh
answer
my
is,
God.
unfortunately, no.
Okay,
Should be
wait. What is
normal.
what is it in Malima? What are we looking for in Malima?
There's an
Something
Excel
degrees
file I
of
think
freedom.
called degrees of
Oh, yeah.
freedom and p-value.
Choking them
Okay. So this is a big, ugly, nasty formula, but it's not too hard to. It's not really that hard to deal with. I just take one variance divided by the n and add it to the other variance divided by n, and then I square that answer. And then I have to divide it by some great big number. Now, if this formula, if you go to La Lima, oh shoot, it kicked me out.
Oh my goodness.
20 minutes.
Oh my goodness.
I'm ready to do it.
Okay.
I think the school's Wi-Fi is slow.
Come on. Yeah,
Oh, there it is, resources. So I got a file here, where is it called, where's it at?
Degrees of freedom.
Degrees of freedom and p-values. and you open that. So, I now have that file over here. And this is kind of a nice little tool,
Holy mackerel.
because it says, what do we have to do?
Enter the mean.
Enter the mean
Standard deviation.
and the N for each sample in the yellow boxes.
Okay.
Okay? So, what's the mean for the girls?
Mean was 38.
Wait, let me find it.
What was the mean? What did it say the mean for the sample, for the girls'
You
sample
can
was?
average 3.
3. With a standard deviation of
1.
1. And you see that it calculates your variance. It goes ahead and calculates it for you.
Oh, nice.
But you don't have to do that because I've already got it set up to square it. And your N is what? How many
16.
girls? Huh?
16.
16. Okay? So there you got that. And then I came over here, and what was the sample for the boys?
2. The mean was 2.
The mean was 2.
Standard deviation is 0.8.
And see, it gives me my variance.
Ooh,
That's nice.
And what's the N?
29.
29.
29 for now.
Okay?
Yeah.
So, now if I come down here and look at this, this is just the variance for each group divided by the N. That's this piece of the formula. This is the standard, the variance divided by N2. That's that piece of the formula. And then the numerator is this plus this, is this plus this squared. And it comes in and it pops in right here.
Wait, what?
Mm-hmm.
Huh?
One more time. Repeat that.
I just
You just showed me.
made a spreadsheet that actually calculates all this for you.
Wow.
So see, this number here is this piece right there.
Okay.
This number here is this piece right here.
Okay.
The numerator is this number plus this number,
Oh, okay.
Square.
Right, okay.
and that's what it says to do.
Right, okay.
Okay? Then the denominator, I have the formula written all out that does all this
Yeah.
and gets
That's
that
ugly.
for you. And it comes in there, and somewhere there should be something that says degrees of freedom on here,
Right there in the blue.
In the blue.
in the blue.
The blue.
So right there, it tells you that the degrees of freedom is 25.7438027.
It's only 20 minutes.
Really?
Oh. What time we started?
No, it's not, it works.
Why does it look like
6,
that?
half an hour.
Because Apple does screwy things to formula, to equation editor. Okay, don't, if it doesn't look right, go and look at the one in the book. I can't help how different computers read different inputs. Her formula doesn't look nice and pretty like this. It tried to write it all as one big strung out set of fractions. And I don't know how to deal with that. So don't worry about that part. You can look in the book, it will show you this, but that's the aspect behind it. And then there's another little formula over here that has, remember when we deal with T, we always had to use the standard error estimate, which is basically just the square root of the part of the numerator. So when you look here, it actually gives me the standard error. I guess that should be in blue too. So if you wanted to take that and put it into blue, because it gives that value to you, I'm gonna make that blue a little bit lighter so I can read it easier. So it sort of gave you all that information. So there's your degrees of freedom. So you don't have to really work at calculating it. All you gotta be able to do is get the mean, the standard deviation, and the end. If you do that, this spreadsheet will give you the degrees of freedom. I gave it to you.
And we can use this Excel for our tests, right?
For anything where you're working with means of two samples, and you need the degrees of freedom, and you wanna use an accurate degrees of freedom, you can use that.
Yay.
So that's, you're allowed to use that.
I think that's the easiest thing. we've
Now.
done so far.
Actually,
Oh.
No.
It's not that hard.
so this gave you a exact degrees of freedom.
Talk too soon.
Basically,
Struggling.
we were just always taught to
Tiring.
use the higher end and subtract one. So I would have, when I was taught to do this, we didn't go through all this hassle of doing this. We would have just taken the 29, used 28 as the degrees of freedom. So again,
Oh, wow.
depending on who you're doing, huh?
It's not that far off.
Yeah, it's not that far off. No, it's going to give you a good estimate. See, computers have made doing things a lot easier to do things more exact. Okay? So you can use this. So this is the aspect behind it. If you don't have a computer to use, take the biggest end. Wait, I take that back. Because there's two samples, you don't subtract one, you subtract two. So if you don't have this spreadsheet and you need a degrees of freedom, you can always just say, take the bigger end and subtract 2, which would be 27, which would be close. If you go to your T-table and you look at it, between 27 and 25, there's not a big difference. See, if I go to my,
I'll put the school Wi-Fi.
is this my T-table?
No.
Do you have Excel?
If I do, I don't know where it's at right now. It's in your resources, you can go and pull it up and print it.
Okay.
I don't know if I have any more printed, I mean, but you can go to, but see, if you look at that, look at what's the difference between 27 and
Oh,
25? 1.314 and 1.316? Ain't gonna give you a big difference.
Like functions.
So you're going to list your degrees of freedom. If you have this nice little sheet, it can calculate it. You're going to be a little bit more accurate. When you're working on WebAssign, they actually use the more accurate degrees of freedom. So to get the homework right, use the spreadsheet. On a test, if you don't have time to do that, take the bigger end, subtract 2,
Right.
and you'll be close enough.
Which one is this one again?
I'm trying to figure out how did the degrees of freedom become 25?
Multiplying.
Because it chugged through that formula
divide.
that I had.
It divided this.
It did this formula.
Yeah.
And that's how it became
Yeah.
25.
I've got this formula programmed in. That if you put in the mean, the standard deviation, and the end, it will go through and crunch through this formula, and it spits out the degrees of freedom for you. So I'm not even making you go through it and do it. It's sort of like that big ugly formula we did for calculating, what was it, B, when we did
Yeah.
linear regression.
Oh yeah, that one.
And then I sat there and said, well, here's an easier formula to deal with. Well, here's an easier formula to deal with. You just type it in and I get it for you.
That's the best one.
They showed up like really
So
nice.
don't fret about this big formula. You can use this. On a test, if you don't have this, you can use a estimation for this by taking this, subtracting 2. Because they're not going to be that greatly different. They're off by a couple of thousands.
Really nothing
Okay?
much.
Can I take a picture of your finger?
Of what?
That, because it's not showing up the same on mine.
It's in the book.
It is?
Yeah, that's where I started out at, is looking at it in the book.
Good, then I can. What
Right,
chapter?
right there, it's in the book, chapter whatever, 11, whatever chapter this is
10.
for 2 tests,
10, chapter 10.
okay? So it's right there. So don't overly fret about that.
Yeah, it's a lot neater that way.
Yeah. So you plug that in. Okay, now I gotta drag this off so I don't show you guys. So that's the answer to part D. It says, what distribution are we using? So we say the T distribution, and we have to enter the degrees of freedom. So we just use that spreadsheet and it calculated the degrees of freedom for us. Now, here comes the tricky part. What does part E ask you to do?
What is the test statistic?
What is the test statistic if using the Z distribution? If using the Z distribution, round your answer to 2 decimal places. If you're using the T, round it to 3.
Okay.
Which distribution are we using?
T.
So we're going to round to
3.
3. So pay attention to what it asks. Okay. Now this one gets a little funky because I'm going to give you. Now, if you think about it, how were we doing calculating test statistics earlier?
The mean of the sample.
We either took the sample mean minus the population mean, and we divided it by the standard error. Or if we were doing proportions, we took the estimated proportion minus the proportion of the population divided by the standard error of working with proportions, right? So guess what? The test statistic is still. Now, this is going to get a little bit funky because I'm going to write it out the way that it actually says. But it's not as hard as what we want to sort of look at. The first thing that we're actually doing is we're looking at the mean of the males minus the mean of the females. Because what we're actually testing is there a difference? So we started off with this. And then normally we go ahead and subtract something, right? I guess I don't want to use that color, I'll use green. And we normally would do the mean of the population minus the mean of the female population. Looks scary. And then we're going to divide that by the standard error, and since we're using T-table, we have to estimate the standard error. Now, I wrote this in green. Can anybody take a wild guess why?
You're going to change
Your favorite color.
Huh?
it. Because you can't.
No, actually, I'm
Can't
colorblind.
see
I can't
it.
see anything that I'm doing. We're actually testing to see if there's a difference between them, right? So what would this be equal to? 0. So in essence, I don't even have to worry about that. This is 0. So basically, the test statistic is the mean of one group minus the mean of the other group over the standard error estimate. Because this is always going to be 0 if it's because thinking about the what did we say? because it's always using the one from the null hypothesis, and the null hypothesis is saying that they are equal, and if they are equal, when I subtract them, I should get 0. So see, all this is really saying is minus 0. But remember, it's the same form, isn't it? We're dealing with the difference of the sample minus the difference of the population. But this is just 0, always will be. Because that's what the null hypothesis says, right? That they're equal. So it is not as scary as it actually looks. So see, now when we're doing our test statistic, it changes just slightly because we just have two different areas. So if I go back to this, how do I get my test statistic?
You take these
Sample.
sample of the males.
You hit equals, and what am I going to type in?
Parentheses.
Parentheses,
Click. Males, right? 2.
okay, the sample of the males, or the mean of the males, minus
The mean of the girls.
the mean of the girls,
And parentheses.
divided by
The standard estimate.
standard error estimate, which is this,
Which is in the blue.
which is down here in the blue. So I get a negative 3.438740, blah, 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 blah.
Wait,
Over here, just test statistic.
sorry,
The mean of the male minus. Now, in this particular case, it's a two-tailed test. See, this is where going back to the picture.
Parentheses.
This is a two-tailed test. So we have stuff out here in either tail, right? Well, we just calculated it and we got a negative 3 point what?
3.4387.
438. Okay. So that's out here. Now, normally we need one of two things. We need a table value to decide, do we reject? Now I can look at this and say, well, it's so far out here that I'm going to reject the null hypothesis. So if I reject the null hypothesis, what does that mean?
In reality, it's false.
In reality, no, that's the type 1 error.